onboard electrical system for 2 engines. This is the first in a small series of videos. Later during the video, I will explain them better. In this video, I want to show you a system, standard to advanced level, for a boat that mounts 2 motors. It may be 2 engines, but during the video, I will explain it to you in 4 parts. If I'm not mistaken, I've taken some notes so that you can get a good look at how each part of the system works. Certainly, the electrical system on board cannot be done simply by 1 motor, 2 batteries, or 1 battery for the utilities, and maybe just by putting a charger on it, whether it is solar or mains. The system has to be a little bit more complex if we want it to work really well. This project I present is just such a plant, how I think it should be done to have efficiency in the boat, safety, and, let's say, everything done well so that you can go out to sea, be quite comfortable, and not get stranded. Basically, there are so many aspects that you have to take your time to evaluate. If you have the patience to follow the video, we will take them one by one. I recommend you follow until the end of this video, because if not, you will miss some pieces and will not fully understand. Let's start with the general scheme. On the left, we have the 2 motors. Here, we have the first part of the system, which is basically a Cyrix. This device, this accessory, is used to charge from the alternator of the engine, both the services battery and the engine battery. This, obviously, is the engine battery, and through its connection, passing through this distributor bar, we are going to charge the services battery. Now, I am only making a general speech to show you the basic elements of this system. Later, we will analyze everything item by item, so don't worry. Here, we have a shunt that is used to control the current consumption of both charge and current consumed regarding the battery and the services. In this installation, I have included an AGM battery, and there will be an upgrade on this plant in which we are also going to look at, possibly a lithium battery. Right now, for the time being, let's move on. This is the bar where all the negatives are connected, the boat's general utilities and the shore charger batteries. Here we have a DC-DC converter. Basically, this is used to isolate galvanically our most sensitive utilities, such as the echo sounder, automatic radar, and VHF. Later, I will show you exactly how it should be connected and how this is to be used as well. Anything else with a reference voltage. We have also 2 switches that we need in case one of these 2 batteries should have a problem. We will have the possibility, with these switches, to bypass the battery. With these 2 switches, we will be able to connect the services battery with the engine battery to allow starting. But now, we will see more in the details of the system. Another thing, all these elements can be found in the description. There will be a link that takes you to a Canva sheet, absolutely free of charge, where you can access it to look at it really well by enlarging it, or possibly even printing it out, so that you can see everything more calmly. Here in the video, we go a little faster. Afterwards, if you have any doubts, or if you want to go into more detail, you will find it there, in this link in the description below. Now, we look at the system in its various parts. This, we say, is needed to understand the layout of 2 motors, engine 1, engine 2, the engine starter battery for engine 1, and the starting battery for engine 2. Afterwards, there will be another screen where we will see in detail all the specifics. This simply serves to show you that the diagram of engine 1 is essentially the same as the schematic of engine 2. There are 2 Cyrixes. Obviously, you can't use just 1 Cyrix. Clearly, there are 2 batteries, one for each motor, and each must have its own battery shunt. Here next to it, there is the shunt and all the other components. But let's move on now. Let's analyze just the system of one engine. First of all, the Cyrix. I chose the 230 amp model because this will be used to start the boat, being able to use, precisely, also the GM battery. If, for any reason, the engine battery should have any kind of problem, from the alternator, we get to the main switch. This is the one that gives voltage and current to the engine, both for starting and for charging. On the upstream part, where there is no voltage, the Cyrix should be connected. On the other pole, a 150 amp protection fuse should be connected. Here, I put it on the distribution bar, in this case, Victron, with all the positives. After that, there is the battery stack, which directs current to the service's GM battery. The GM battery is connected to the negative and also to a smart shunt. This one will be needed to have everything under control in the dashboard, such as voltage, current consumed, power, etc. This will also provide information about the engine battery because it has an extra input. In case we need to check both batteries, it is better to always put a two-position diverter switch. On the diverter, we will have motor battery 1, motor battery 2, and we can control both voltages. The AGM battery, on the other hand, is connected directly and will provide voltage directly to our instrument. The first thing you can notice is that this shunt is powered through this line with a small 5 amp fuse. It is always powered, that is, it is always connected to the GM battery on the positive pole. This is important because the shunt and the instrument basically store the maximum capacity of the battery. Once charged with a charger, it recognizes that as 100% and calculates, correctly, the remaining percentages in the battery. If we connect it upstream, every time we disconnect the main switch, it will lose this data in memory, and the readings will no longer be reliable. In short, it won't provide the right reading. I put a 150 amp fuse, not for the charging current, which, very rarely, will be that high. Alternators normally range from 40-50 amps up to the biggest motors, which are 90-100 amps. However, this fuse is for us to limit the current at the time when we need to transfer energy from the service's GM battery to the engine battery. So, in case of failure of the engine battery, we have this system and this fuse. We need it because if the engine battery is shorted, this will save us. It will not allow too much current to pass through the Cyrix. Also, this Cyrix can be of different models. The one I chose is the biggest one, 230 AA, but there are also smaller models. So, it will not damage the Cyrix, but will simply blow the fuse or the thermal magneto that we would put here. Someone might say at this point, yes, but if I attach the engine battery, there's voltage here, and there is voltage here too. If I start the engine at this point through the Cyrix, the current goes through this pole. It comes here, and here I have the Victron distribution with all the positives. Wait, I went ahead. With all of the positives distribution, I find myself with current here, even with the main switch in the off position. No, well, that can't happen because the Cyrix, if it doesn't read a minimum voltage of 3-4 volts, does not activate. So I can start the motor, even get to 13.5 volts at this point, but still, it will not shut down. It will not allow current to pass, so here it will always remain at 0. When I connect the service's battery, which can also be very low, but still 3-4 volts, it will detect this small voltage and then allow the current to flow to charge the service battery. Each Cyrix will have its own button that needs to be placed on the dashboard. Once activated, this button closes the Cyrix for 30 seconds, allowing it to also work in reverse. For example, if the engine battery is low and I want to start the engine, I press the start button. For 30 seconds, the Cyrix will connect my service's GM battery through the same line, in reverse, to the engine battery. At that point, I can start the engine. After 30 seconds, it will disconnect again and return to its normal operation. Normal operation means if it detects a voltage over 13 volts here, it will also start charging the service's GM battery. And this is the board, let's say. That is about the Cyrix system. Now, let's move on. This concerns, let's say, our voltage monitor, which I always recommend installing in the boat. It is very important to know the consumption of our utilities, not so much for fear of running out of power, but, for example, if the live tank pump has a problem. You will see that from the 5-6 amps it consumes, it may suddenly consume 8-9 amps. We will notice this abnormal consumption right here because we will see more amps of consumption. This way, we may catch the problem in time and solve it. And this is something, in my opinion, I really appreciate. The same goes for all the other utilities. If we have something shorted, something that is not working, etc. With our system monitor, we will always have control of the situation. Plus, we will always know what percentage of battery power is left available in the boat. In my opinion, this is a very useful tool. With a single clock, you can read both the service's battery and also the 1 or 2 engine batteries on the other side. As I explained before, while we are here, let's look for a moment at how the system is structured. The AGM service's battery line goes through the main switch. Here, I can turn it on or off. When I activate it, I feed a distribution bar, Victron, which must have big fuses. Here, for example, there may be, and in fact, there will definitely be, the voltage stabilizer for all our electronics. For example, from the battery, we will have another line going to another bar, a positive distribution with fuses, which, however, will always be energized. As you can see, it does not pass through this main switch. Why? Here, the battery charger will be connected. Solar chargers must be able to charge the batteries always, even when they are disconnected from the main switch. Here is another example, the bilge pumps. In this case, I have connected them to the service distribution bar. They can also be connected to this bar, a positive distribution with fuses always powered. In this way, even when disconnecting our main switch, we will continue to energize the pumps with the automatic system. Now, let's look at the stabilized part of the plant. This part here is used to power all of our electronics. We have the Orion TR1212. This device, you can find it with different amperages, 9, 18, and it can also be put in parallel for even more power. We have an input coming directly from the positive distribution bar, always under a fuse, which is correct for our Orion. The Orion we have chosen should be connected to the center negative bar, the one we saw before. This is connected to the zinc outside the boat. The output, again negative and positive. Be careful not to connect these two negatives. Even though both are negatives, they are actually different. This is galvanically isolated from this negative. This means that if we have a disturbance, for example, from a pump, the pump of the live fish tank, or even from the engine or the alternator itself, with this tool, this device, I can separate the two currents, the two voltages. So, it will not pass the disturbance that maybe is also on the ground wire, the negatives. It will not pass to the other negative, which is therefore isolated. With that, I go to another isolated negative bar that serves only the electronics and the positive on an isolated distribution bar, always for electronics. In this case, I wrote 18 amps, but I drew a TR12V 9 amps. So actually, here it would be 9 amps maximum of consumption. Consider that, on the instrument manuals, you will see that a 12-inch instrument normally consumes 2.5 amps, 3 amps maximum. So, even with the 9 amps, if you add up 2 or 3 things you have in the boat, you will see that you stay within it. Be careful only with the autopilot, because it has a pump that consumes a lot. In that case, you will need to provide something bigger. Be careful not to connect things like, for example, the MNAA 2000 of your electronic system with the MNAA 2000 of the engine. Why? Because in this case, the ground will again be connected via the MNAA 2000 between the isolated negative bar and the center negative bar, which we said we do not want. So we have to keep the two networks separate as well, the MNAA networks. This is to avoid having disturbances of any type. Now let's talk about the battery charging area. Here, there are also some new things that you have to be a little bit careful about. First of all, what is this that you don't normally see on the schematics? This is a ground isolator. It is called a VDI. It can be 16 or 32 amps. The dock receptacle has the phase plus the neutral, and they are schematized with this gray that I drew here, plus the ground wire. The ground wire is to be brought here on the first pole. This is the galvanic isolator, a galvanic isolator. The output is on this side. This tool here is essential when we go to connect. With the Navy plant, because it is not necessarily the case that the ground of our Navy is equipotential with the ground we have on the boat. In fact, it normally is not. If there is a difference, even a very small amount, half a volt or 1 volt are zincs, when we fit them, as well as other metal parts, such as the foot of the engine, the propellers, or the rooters, will wear out and be ruined. With this galvanic isolator, we solve this problem. Of course, if you have an outlet at the dock that you use for only 1 hour a week, this will not be necessary. But if you leave it connected on the boat for multiple hours or multiple days, then, at this point, I say to you, it is absolutely necessary to have this tool to safeguard everything. So, as we said, the two phases enter here into the thermomagneto with a differential. This is also essential in order not to get electrocuted on the boat. It must be connected as ground to the central negative bar itself. Next, there is a thermal magneto for the boat services. This is a thermal magnet used to energize and turn on or off our Phoenix Smart Charger, which is the charger I chose to charge our batteries. Why did I choose this one? Because, in my opinion, it is the best and it works really, really well. It is very functional and performs excellently for a boat. There are cheaper models, but they are not as suitable for a boat. Those are good for campers. This one, however, is also protected from humidity and splashing water, etc. In addition to our isolator, VDI 16 or 32, here we have the Phoenix that we just saw. It has its fuse, which connects to the positive distribution bar with a fuse that must always be powered. This goes directly to our GM battery. If we were to install a solar system, we would have to obviously add another fuse on this distribution bar, connected to our solar charge system. But already here, I can tell you that I am preparing 3 more videos for options and additions to this plant. This is the basic plant, where we have all the most important components. However, it can and will be integrated with 3 additional features. Remote control. There is an accessory called CERBO that allows us to control all the most important functions on the boat: the power supply, the batteries, a pump in operation, the fuel levels, and so on. Solar charging. I will also show you the exact schematic to set up the system the correct way. Battery upgrade, transitioning from a lead AGM battery used for services to a lithium battery. These will be 3 additional videos which I will make individually because the requirements are really specific. In fact, with this same system, I will always use Victron products. In the description, you will find a link. I have made an agreement with Fishfinder Store, and I was able to get a discount for you. You will need to use the discount code found in the description. Check the description for all the links to the products you need to set up this installation. If you have any doubts, comments, or suggestions, please leave a comment below. I always read and answer them. As you have seen, if you have specific needs, write them in the comments. If multiple people have a similar problem, I will make an ad hoc video for you. Said this, I thank you for your attention. To all those who have stayed until now, if you enjoyed the video, leave a like, subscribe to the channel. For me, it is very, very important. See you in the next video. Hello, everyone.